A chemical equation has a reactant formulas on the left of yield arrow and product formulas on the right. Here, the A plus B are the reactant formulas and C plus D are the product formulas. The symbol is read as yield. To present a chemical change quantitatively, the equation must be balanced. That is, the same number of each type of atoms must appear on both sides. As an example, here is a description of chemical change that occurs in many fireworks. A magnesium strip burns in oxygen gas to yield powdery magnesium oxide. We know that this reaction results also to light and heat, but here we are only concerned with these substances. We will write and balance the equation in a step-by-step manner. 1. Translate the statement. A magnesium strip burns in oxygen gas to yield powdery magnesium oxide. We need to identify the reactants, which are the substances that react with each other. Here we have magnesium and oxygen. The oxygen is a diatomic molecule, so it exists as our product will be magnesium oxide. So we have, at the beginning of balancing the equation, we put a blank in front of each formula to remind us that we must account for its atoms. Number 2. Balancing the atoms. Match the number of each type of atom on the left and right of the yield arrow. In each blank, we are placing a balancing stoichiometry coefficient. Balancing is easiest when we start with the most complex substance or one with largest number of different types of atoms. In this case, MgO is the most complex, we place a coefficient 1 in that blank. To balance the Mg and MgO, we place 1 in front of Mg on the left. The O atom in MgO must be balanced by 1 O atom on the left. 1/2 of O2 molecule provides 1 O atom. Hence, in terms of number of each type of atom, the equation is now balanced. Now number 3. Adjusting the coefficients. In most cases, the whole number coefficients are preferred. 1/2 of O2 molecule cannot exist, so here we need to multiply the coefficients to have all coefficients as whole number. A coefficient of 1 is implied by the presence of the formula, so we don't have to write it. Now number 4. Checking. After balancing, always check that the equation is balanced. For the left side, Mg equals 2 times 1 mole of Mg is equal to 2 and O equals 1 times 2 mole of O is equal to 2. For the right side, Mg equals 2 times 1 mole of Mg and O equals 2 times 1 mole of O. Now for the number 5 step, specifying the states of matter. Lastly, we need to indicate the physical state of each substance. The notations are G for gas, L for liquid, S for solid, and AQ for aqueous. From the original statement, we know that magnesium strip is solid, and oxygen is gas, and powdery magnesium oxide is also solid. Hence, we now have our final and balanced equation. If we visualize this, it looks like this. 2 moles of magnesium plus 1 mole of oxygen yields to 2 moles of magnesium oxide. Now let us try another problem. Within the cylinder of a car's engine, the hydrocarbon octane, one of the many components of gasoline, mixes with oxygen from the air and burns to form carbon dioxide and water vapor. Write a balanced equation for this reaction. So step number 1, translate this statement. So we have step number 2, balance the atoms. Start with the complex C8H18 and balance O2 last. The C atoms in C8H18 end up in CO2. Each CO2 contains 1 C atom, so 8 molecules of CO2 are needed to balance the 8 C atoms in each C8H18. The H atoms in C8H18 end up in H2O. The 18H atoms in C8H18 require the coefficient 9 in front of H2O. There are now 25 atoms of O on the right, 16 in 8 CO2 plus 9 in 9H2O, so we place the coefficient 25 over 2 in front of O2. Now step number 3, adjust the coefficients. We need to multiply by 2 to obtain whole number coefficients. Now step number 4, checking. For left side, C equals 2 times 8 mole of C, which is equal to 16. H, 2 times 18 mole of H, so 36. O is 25 times 2 mole of O, so equals to 50. For right side, C is 16, H is 36, and O is equal to 50. Now for the last step, specify states of matter. So now we have our final and balanced equation.